Thanks for the introduction. My name is Poorna. I'm from the University of Notre Dame. Today I'll be presenting our paper on replicating user-defined gestures for text editing on tablet devices. And I'll begin by asking you all a few quick questions. So, how many of you use touchscreen devices regularly? We all do, right? And how many of you use these devices for text entry and editing, be it sending emails, messaging? And how many of you use a stylus regularly with these devices? Okay. And how many of you regularly write on paper with pen and pencil? Okay, thank you. So I asked you these questions simply to make this talk more relevant to you, and your responses are actually very similar to the ones we got from our own participants in the study. So what's text editing like on these devices? It can be cumbersome, right? You first have to position the cursor with your finger, and then widgets or carets appear using which you can select text more precisely. And then usually text editing is involves two steps on these devices. You first have to position or select and then choose the action to perform. And given the advances in stylus technology and improved digital handwriting recognition, handwriting can actually be considered a promising alternative. And it combines the ease of writing as well as and affords features of digital documents. And we have this vision of an ideal handwriting application that enables handwriting and recognition anywhere on the document. And we share this vision with researchers not only in the present, but also researchers like 3 decades ago when tablet devices had just been introduced, and they lacked a lot of the capabilities which are available on today's devices. However, despite our modern devices being very capable, our current handwriting applications are not very intuitive. For example, you have to write in designated boxes, which then gets converted to typed text. But they're getting better. For instance, this is MyScript's Nebo app, which actually lets you convert handwriting by simply tapping on it. And this paper actually focuses on devising intuitive gestures for text editing for such handwriting applications. And to do that, we draw inspiration from and we replicated gesture illustration studies from papers that did this work 30 years ago. And those were by Wolf and Morrell Samuels in 1987 and Wellborn and Whitrow in 1988. So what is gesture illustration? So we elicit gestures from participants. That is, we give them the results of an action or task known as reference, and we ask them to come up with a gesture that would result or produce that referent. And for example, this is the referent for the insert word task that we used in our study. So we gave them, we told them what the result would be, and we asked them what gestures they would perform that would result in that referent. So our goals for this study were to come up with a gesture, a user-defined gesture set for text editing through a gesture illustration study. And we also wanted to study the influence of modern device usage on the gestures the participants performed. So we allowed them to use either finger or stylus to perform the gestures. And we also, of course, wanted to compare our findings with those of the earlier studies that we replicated. And we recruited 20 participants who were all either undergrad or grad students in our university. And they all use touchscreens frequently, but they rarely use stylus on them. And they all wrote on paper regularly. And we used a within subjects design where all the participants were required to devise gestures for 20 tasks. And these were the 20 tasks that we used in our study. And we labeled our tasks based on modern device usage. So we used an Apple iPad Pro and Apple Pencil for our study, and we built a low-fidelity prototype, which was used to present the tasks to the participants and to record their gestures, and the prototype did not respond to the gestures. And the participants were first given a practice task, and as mentioned before, they were allowed to use either their finger or stylus to perform the gesture. And because earlier studies have shown that participants usually considered the recognition aspects when devising gestures, we told them, and to not constrain their inputs, we told them to assume that the implemented interface would afford handwriting and recognition anywhere. And they were also asked to think aloud and tell us what they how they expected the system to respond to their gestures. And we began our analysis of the data collected by grouping the gestures. So we collected 400 gestures from 20 participants, and we used open coding to group the gestures. And we grouped the gestures based on their underlying semantics. So for instance, many gestures differed in their appearances, but they were semantically similar. Like for example, in the example shown for select phrase task, the first two gestures are considered semantically equivalent, like enclosing using either parentheses or brackets, but the third one is considered semantically different. And we also calculated the agreement scores for each referent. That is, it is a measure that tells us to what degree the participants agreed on gestures for a given referent. And you can find more details on that in our paper. And lastly, we finalized our gesture set by not only selecting the gesture that most participants agreed on for each referent, but we also included aliases and extensions, which I'll talk about next. So aliasing involves adding synonymous gestures for a referent rather than providing a single specific gesture. And this is usually done, this practice is usually followed so that the recognition rates are increased and to provide more flexibility and to not make it more stringent. And we also added a couple of extensions to our gesture set. So if based on the size of the tasks. So for instance, for the select multiple lines task as shown in the slide, the first gesture was the dominant gesture that was used by most participants. But in this, for the purposes of the task, we had the task consisted of text, only 3 lines of text, but in practical scenarios, you can expect the text to be much longer. And so we also added a gesture that would consider the size of the task as well. And this gesture also came from the collection of gestures that we obtained from the participants, but it wasn't the dominant one. Now I'll talk about some of our findings. So we first compare our gestures, the gestures that we obtained with those of the earlier studies, that is Wellborn and Whitrow study and Morrell Samuels and Wolf study. And they were actually largely similar, and I'll present some examples next. But there were also some differences as well. And all of these gestures, they reflected the mental model of annotating on paper. For example, if you look at, so the gestures for the left side shows the gestures that were obtained in the earlier studies, and the right side is our study. And so for the insert character, word, and phrase tasks, the gestures obtained were almost identical, and it was the same for delete character, word, and task and phrase as well. And it was the same for move word as well. However, there were some differences too. So we got different gestures for join, which is equivalent to delete space in our study, and split, which was insert space in our study. And we suspect that this was because of the phrasing of the reference. And like I mentioned before, we phrased our reference to be consistent with modern device usage. But however, our gestures were also contained in their aliases. And we also had additional tasks in our study that were not considered in the earlier studies. And these included the select tasks, delete long phrase, and so on. And now I'll talk about legacy bias. So legacy bias is a term that that is used to illustrate the influences of users' experiences with devices that they've used previously. So we wanted to study the influences of like modern device usage and on the gestures that the participants came up with. So while the paper metaphor was like very dominant, we also obtained a few gestures that were influenced by modern touchscreens and the desktop paradigms. So for example, 3 participants used their stylus to tap and hold, and they expected the cursor to appear, and then they wrote the word for insert word task. And in another example, one participant used the pinch and zoom gesture to insert space between 2 words. And next I'll talk about, so we allowed participants to use either their finger or stylus, but we found that most of them, like 90% of them, used stylus alone for their gestures, and the other 2 participants used their finger for like a select few tasks, but then later switched to the stylus for the majority of the tasks. And this is because stylus affords greater precision, and one can easily transition between handwriting and editing. And this is in line with what is known about stylus-based interactions in general. And we actually found some surprising behaviors regarding how participants treated white space. For example, for the insert word task, most participants wrote the word and like they found existing white space in which to write the word, but a few others did not, like such as the second example in the second example shown on the slide. So this made us think that these behaviors probably signal that a dynamic white space window may be an ideal method for supporting in situ text entry. So that is when a user intends to enter text, a dynamic window should be created, and this window should be dynamically resized as the text is entered, and in much the same way as when typing using the keyboard. And another interesting behavior that we saw was when most participants treated white space as a manipulable object, that is, they directly manipulated it. So when they were asked to delete a blank line, they directly crossed it out, or like they used strike through. But there were also a few participants who moved the text below the white space upward to delete the blank line. So this was another interesting behavior that we observed. So, and these examples suggest that white space manipulation in the context of digital handwriting applications can be quite complex, and it needs further attention. And with this, I end my presentation, and I'd like to thank my co-authors, Jason, and my advisor, Ron Metoyer. And I thank you all for your time, and I'm happy to take questions.
Thank you very much. We have time for a couple of questions. So if you have any, please walk to the microphone and ask questions. Okay, so I will start with one. So you presented basically gestures that were elicited by your participants for text editing. Right. So did you consider maybe just checking whether the gestures elicited by the participants were understandable in a text editing task, like asking participants to perform gestures that would mean I would like the text to be edited like this, and then giving the annotated text to somebody else that would edit the text and check whether it was like the first participant was expecting?
That would be an interesting thing to do. We didn't do that, but yeah, that would be an interesting thing to do.
Was it conducted in the previous studies that were run in the 80s on paper?
No. Oh, so one of the studies was done on paper, like they used paper and pencil to elicit gestures. The other was used on one of these tablets where like they had a separate display for the tablet. Yeah, so one of those tablets where they had a separate display and the tablet was separate. So they conducted this study on such a device.
Okay.
Thank you. I didn't see your entire talk, but what I saw was very interesting. So I have a question, maybe slash comment, but so can you tell me again what exactly you did in legacy bias?
So legacy, so for, we wanted to see what, so how like modern touchscreen device usage, like what I showed in the, one of the earlier slides. So how these interactions influence, like if they, first of all, if they influence their gestures, and
And would
how they
that be
influence their
good or
gestures.
bad?
Huh?
Would that be good or bad? The fact that it's influenced by the legacy bias.
Yeah. So
Is it good or
like,
bad?
So that, okay, so this is the thing. Legacy bias is actually like a debatable thing. So some of them, there are people both for and against it. Some say that it's necessary to take into account people's experiences with previous things, but some others say that that shouldn't be done because they may not know like better ways to do things too. So it's actually a debatable concept, but we are on the side of folks who think that it can be useful, because if they're used to something, then they'll better remember it. And so
Thank you.
thanks.
Okay, so if we have no further question, we will